So first things first, let's double check the schedule. Somebody brought to my attention that you guys might be going down to Phoenix or something. At the end of the month? The last weekend of the month? No or yes? Or? It's the what?
27th and 30th.
So it's that Thursday to
No, Friday or Saturday, or Sunday.
Friday and Sunday? All right, so what I'm going to do is I'm going to leave the 31st as a suggestion here. But if we need to push, if you can't turn it in until the 1st of November, that following Wednesday, that's fine. I mean, I could make it due before that, but I don't want to. What about November 16th? Anything popping up that day? What do you guys have? Structures, CTEC? You have ECS? Yeah, you don't have ECS yet, not until spring. Structures, CTEC, Studio, what else? Come on. Structure, CTEC, what else? Studio, and then just some other classes? Just outside of the School of Architecture in the fall? Please help me, I don't remember. What? Other classes, or is there anything else in the School of Architecture? Is this training that? All right, so that would be 12, probably have another class to here or there. All right, so, I mean, if you don't have anything due on in those classes on November 16th, then I'll leave that as a deadline. Come on, it's 10 a.m. You guys act like it's like 5 a.m. in the morning and it's like the crack of dawn and nobody's paying attention and like, come on, like just level with me. Is this doable? Is it fair? Okay, great. That's what I want to make sure of. That's always my deal with you guys. I just want to be like forthcoming, communicative, and let's make sure we're on the same page. All right, so we'll stick with this then. I understand some of you might be hungover from the long drive back to Phoenix on Sunday evening, in which case maybe you can you'll say, well, in which case it'll be due the 1st of November. But I'd like for those who aren't going to shoot for the 31st of October. And you will get a leg up on doing the final prototype then, for those that are able to get it done, the first one done sooner. Okay? All right, so let's talk about what we're doing today and what you're going to do over the weekend. Here we go, building the parametric prototype. I already have the obligatory blank space where we will post today's video from the recorded lecture demonstration that we're recording at the moment. But over the weekend, right, you're going to take what we're doing today and do it with your own component. So you'll build it in Grasshopper. I'll show you how you can change some of the sliders and variables. Take 3 different screen captures of it to show how it can change a bit. Right? Upload those by Monday before class. All right? This just takes you right to an assignment that made in Canvas where you can, it's basically the same instructions, right? All righty? All right, so I'm going to do this for just a generic component that I was playing around with right before class. Okay? And you're going to do it for your component, right? Over the weekend. So let's just talk about what these steps look like. Right, so I had this sort of obligatory, here's a half a pyramid, here's half a pyramid with the open up link converted on. And then afterwards I was like, wait, no, actually if I put one extra fold in each of these, right, I can make an aperture here in the center, but I can also make apertures along the edges. And that can be adjusted with sliders as well. Ooh. Right, so, if this was me, maybe I'm doing this on a paper or whatever, let's talk about it like you guys have, right? So you would have a prototype that looks something like this or that or whatever, right? Yours are all different, but you get the idea. So from the paper prototype, it's very simple. This is what I do. I get out the paper and the pen and I just start to sketch a little bit, trying to figure this thing out step by step, right? Very simple diagram. Took me literally 30 seconds to do. took me longer to write these steps than it did to actually draw the drawing, right? So what did I start off with? Just a quad, square, rectangle, and axon, right? Then I'm sort of mapping things out. Where do I need points? Where do I need to project up? Where do I need to project out? What do I need to do in order to connect these things up in order to create these triangular surfaces that are basically folded paper surfaces, right? Okay. And so, step by step, I'm sort of thinking about this. You know, let's get the vertices, you know, the 4 vertices of each of this, what do you call it, this quad. Let's evaluate the surface at 2 different points, one towards one corner, one towards the other corner. Let's project up from there with the normals using that start point direction length line tool. And then from there, we get a bunch of points in space to start to connect up, right? To connect the dots. All right. This is how I recommend you start, right? Like you look at your paper thing and say, okay, I have my frame, that's the quad, draw that. Now, I can build from this quad, how do I begin to build this component? All right, so let's do that. I'll do this from scratch, why not? Should have Rhino starting up in the background. Here we are. All right, so I'll keep this up so we can refer back to it, and then I'll keep this up so we can refer back to this one when we do a second one. All right. All right, so let's think about that recipe. I just made my algorithm, right? This is the way to make my toolhouse cookies from this quad. Just going back to the very first day, right? All right, so let's do this in Grasshopper. I'll open it up. What's the starting ingredient? What's the ingredient I need? It's not flour or chocolate morsels or vanilla extract. What is it? What do I need? What do I need? Quad, yes. I need a quad. I can make this component on any freaking quad you throw at me, right? If I make this from a quad, that's the starting ingredient, the only ingredient I need, then I can make hundreds, thousands of these, right? All I need is a quad, or hundreds or thousands of quads, right? All right, so options. Let's see. And that's typically how this works, right? You have sort of like starting conditions, right? Again, when I break down a surface, the easiest way to do that is to break it up into smaller pieces. And the easiest way to sort of take a nerve surface or really any kind of part of an envelope, building envelope, is to start to break it up into quads. What are half of quads? You cut them diagonally, you get triangles, right? Very simple. We talked about this with the planar fabrication structures presentation the other day, right? So, all right. In Rhino, I'm just going to draw a quad. Do this several different ways. I'll just use the corner to corner. Let's make a rectangular plane sort of dude right here. There we are. And I will set this to ghosted or something like that. And let's just take a look-see. All right. Here we are. All right. I have something in Rhino. I want to bring it into Grasshopper to build up with it parametrically. What do I need to do? You go to my params tab, right, and find different type piece of geometry that I need, whether it's a point or a curve or a surface or a mesh or a polysurface or a number or a vector, right? It's all here. Vector surface right there. All right. And I can right click and say set one surface, Grasshopper disappears, showing me Rhino, allowing me to select the Rhino geometry that I want to reference back into Grasshopper, right? We've been here before, right? Okay, yeah. Great. Now I can even turn this off and just see just the Grasshopper preview of it, right? There it is. Ta-da. All right, so visually maybe this helps us see a little easier. What's next? Here's the recipe. What's next? We start with the quad. What's next?
Yeah, vertices.
That's right. Damn it. We're going to get all 4 vertices of this quad, right? Since it's a quad, we know it has 4 sides, and therefore 4 vertices, right? It even has a little face, right? And so let's do that. Let's take this piece of geometry, let's explode it to find all of its constituent pieces, right? So I'm going to go to the surface tab, since that's what we're dealing with here. I'm going to go to analysis. I'm going to say deconstruct brep. This is a really interesting little widget here. Besides looking like a, some sort of like piped surface, like exploding or something or on fire, just kind of a cheesy icon, right? Once the polysurface or brep, right? That's just a fancy word for polysurface. Now it's going to give us any faces, any edges, any vertices. We're just going to give it one surface, and so it's going to be really simple. We're going to get one face, right? 4 edges, 4 vertices. Vertex 1, 2, 3, and 4. You can see they're just a simple list of 4 vertices. And if I move my cursor up, I get a list of 4 edges, right? Basically 4 curves, line-like curves in this case. I like how specific that is. Interesting. Anyway, and so since these are a list of 4 items, we want to be able to pick out the first and second and third and fourth and start to connect things around, right? So let's break out each of these out. Since we're using quads, right, the logic here is that we're always going to have 4 in this list and 4 items in this list. And so what I'm going to do is I'm going to go to my sets, right? This is where I can do all kinds of things with lists and sets of stuff, right? And remember way back when we used to do this, I'll pull out a specific item from this list, right? So here I can plug in a list. In this case, it's going to have a list of 4 items. And then down here, it asks me for an index. In other words, it's saying, do you want the first item from that list, or just the second item from that list, or the third item from that list, or the fourth item from that list, right? And so I give it an index in order to sort of tell it which item in that list I want, right? So I'm going to plug this in. Now you notice the index is set to 0. What does that mean? So let's think about this. You guys, type things in Word, Microsoft Word? Right. I think you all do. Yeah, okay. Or have. Right. You know how there's like bulletin and you can have numbered lists, right? It starts with 1, and then 2, and then 3. Particularly when you do outlines, it comes in. Okay? Computers do the same thing. When we have a list of items, we have the first, the second, the third, and the fourth in this case, right? We have 4 items. Not a big surprise, right? First through fourth. However, when it actually enumerates that list, that bullet points that list, right? Instead of starting at 1, it starts at 0. Computers start counting at 0. It's really annoying. It's the most counterintuitive thing you'll ever imagine. And it's usually the goofiest errors that it forces you to make when you're really tired and sleep deprived. However, if I want the first item, I give the index of 0. If I want the second item on that list, I give an index of 1. So it counts up, right? And so if we thought about this, it's really odd, but if we started our outlines, instead of the first item starting with 1, we started with 0. I know, right? Pain in the rear. But there it is what it is, right? And so that gives me just this one item, right? You can see the x-coordinate starts with 12, negative 12 or whatever. You can see, yeah, it really is that first item there. So let's try it again. Let's make a copy of this. I'm going to copy and paste this. I'm going to change the index, and I'll set that integer to 1. So now we'll get the second item in that list with an index of 1. And there it is, 21.7 blah, 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 negative 0.717. Yep, it's that second one, all right. All right, so we can sort of confirm that we really are pulling out the first, the second, and third, and the fourth in their own little widgets here by doing this. I'm just going to copy and paste, change each of these each time, right? So if I want the third item, an index of 2. If I want the fourth item, an index of 3, right? I'm just right-clicking on the index input, going to set integers, right? And I can do it right there. All right. So as I move around, you can see I select this one. There's the first vertex. There's the second vertex. Here's the third vertex. And here's the fourth vertex, right? So we have 4 points in space now that we can begin to use for our sort of geometric jigsaw puzzle of trying to connect things to simulate surfaces made out of paper, right? And eventually chipboard. What's the next step? I want to start locating certain specific points on the surface itself, on that face, right? In this case, I'm saying 0.25 and 0.25. That's your UV coordinate, that latitude, longitude, right? Quarter of the way in 2 directions. And then 0.75, so 3/4 of the way, 3/4 of the way, also in the same direction. Does that make sense? I found that just looking at it and sketching it out really does help, right? Yeah, okay. All right. Especially when my voice sounds like Kermit the Frog. Better just to talk through drawing. All right, so we have the surface. We need to evaluate it at that UV parameter, right? And we have two different UV parameters to do. So let's do that right now. Let's see. This is a surface. I'm going to go to the surface tool. Remember, we can evaluate the surface at a UV parameter. There we are. Okay. So with a curve, we can evaluate a curve at a T parameter. Surface, we get U's and V's. I don't know what happens when they run out of letters in the alphabet and they get down to Z. But anyway, so there's a couple things here, right? We need to plug in the surface. We need to plug in the UV coordinate. We need to tell that to reparameterize the surface so it's from 0 to 1 in both directions, right? Otherwise, it might just be like some random stray length here, right, for U and V. So reparameterize, plug this in, and just like we have a single number slider, we also have a multidimensional number slider here. So we can move this in two different directions to give us our UV coordinate. In fact, there it is. Oh yeah, look at that. Okay. I'll get this thing close to 0.25 and 0.25. I don't know how. There we go. Now what's great about this is not only does it give us the location on that surface with the point, but it also starts to query a number of other properties for this. In fact, we can see that it populates that plane with the plane. That plane, and its orientation is tangential. So, you know, what you can do is you can begin to sort of think about the latitude and longitude lines. If they have any curvature to them, you'll find the tangent for that curvature and then use that to construct the plane, right? That's important when we're doing a doubly curved dome, like you will be, once we take this recipe and apply it to 10 by 10 matrix of these things across the grid shell. For right now, however, we're just going to use a plane. So we know that understand, probably intuitively obvious, right? Even if you're just casually observing, that both of these lines, the U and the V's, are just going to be straight. And therefore, we're just going to have a plane that's going to sit on the XY plane, basically, right now. Right? It also gives us the normal, so the perpendicular to that plane, which is really important as well. Okay? Just going to go ahead and make copies of these and put them right here. And I'll just make another point. Just zoom in. Give this other friend a point of friend here. There we go. Happy little points. This happy, nice surface. All right, there we are. Great. All right, so we have 0.25, 0.25, and we have 0.75, 0.75. And what's next? Well, we need to draw normal lines, so we need to project upwards, right? These sort of dashed lines, these arrows, sort of get these peaks, right? Yeah, just think what the Egyptians could have done with the pyramids. But nevertheless, I think we're going to make shading components with these. So start point, direction, and length, and that's the first widget I'm going to pull out here. So I'll go to curves, primitives, look at all these line tools. There's line by start point, direction, and length. And this will be my start point. And the normal direction will be my direction. And then for a length, we'll make that a variable. We'll give it a little number slider here. I'm going to give it, constrain it from, let's say, minimum -5 to maximum +5. Let's see what that looks like. Sometimes the up is down or the down is up. There we go. That works. Maybe I'll change the minimum maximum here while I have this up once. -10, make it just a little, and 10. There we go. Haha. All right. Great. And I'll do the same thing over here. So copy and paste this, and I'll replace the starting point and replace the direction, right, and make a point off of this point with its normal. Yeah, there we are. All right. We have those lines. We need their endpoints, right? We need those points right where they hit in space. These are going to be our peaks in order to start connecting things up. And so I can query any curve and find all kinds of properties, including their start and their end points right here. So part of this will be a refresher. There might be a few new tools in here, but you can go back through the video, sort of follow along, sort of understand what I'm doing. Right? So I can start to play off, and I'll do this here in another step. for a different widget that adds a little more complexity, we'll start to build off of the edges of this quad. Right now, we're just building off the face and the surface itself, and then the vertices. Right? So we're starting to build more constituent geometry, same stuff we've been doing with points and lines. All right, great. Fantastic. I think we're just about done here. Indeed, we can connect the dots. I think that's a great idea. Let's start connecting these bad boys, right? So, what's nice about triangles, and that's what I've been working with here, is that triangles are always planar, right? 3 points in space, it's strike a plane. Period, right? Okay, great. And so, if I know that, I know that they can be planar, then I know they can actually unroll flat out, right? There's no curves or weird kind of stretching, tearing, bending that might get in the way of me and my intentions here. So, let's do this. I'm going to start building triangular surfaces. You can see that a lot of these tools, just like we were talking about the other day in Rhino, right? Native Rhino environment. You're looking at the tools, right? There's extrude and sweep on 2 rails and loft. And, you know, they're all here, right? Revolve, revolution, whatever, right? Same thing, right? I could give it 2 corners, I could give it 4 points or 3 points or edge curves, right? So most of these have some sort of equivalent. There shouldn't be too many surprises here if you compare this to most of the native Rhino surfacing tools. That 4-point surface is what I'm going to look at, right? So you can build any surface out of 3 or 4 points. This is great. And it's literally, the inputs are 4 distinct points, right? You'll start to actually build a triangle if you just plug in the first 3. So I think this is what I'm going to use. All right, so let's think about this for just a moment. I'm going to expand my grasshopper view here so I can see all, oh, come on, there we go. So I can see 1, 2, 3, and 4 vertices, right? I can also see these endpoints. And I'm just going to start connecting the dots, right? So let's say I want to start with this point. Plug that in for A. I can always select the widget and sort of see what highlights green in Rhino to understand which point I'm actually selecting here. So now let's say I want this point. Yep, let's try it. So I'll plug that one in. And I want this top point. Which one is it? There it is. It's the end point for this widget. There. Yeah, not so bad. All right, I can move around and let's see. Now I want this point. All right, so let's put another widget here. And I have to put a widget for each triangle I'm making, right? I want that point again. I want this point again. And then let's see, is it that one? Yeah, it's that one. Oh yeah, there we go. All right, so there's the bottom beak, the bird's mouth, supposed to say, right? Okay, so let's do this again. Why not? All right, I'm going to be connecting this to this to this, right? Let's try to move these in place. This to this to this. All right, so let's figure out where these points are located. There's this one. So plug that one in, and there's that one. Oh yeah. And there is that one's. Start to understand maybe cognitively the relationship here, right? I made a copy and paste, and they kept all the connections. So I'm just going to say disconnect really quickly. And sometimes that can be more confusing than it's worth trying to save time from moving your cursor up here. So let's see. I'm going to go from here to this. So let's see. There it is. So there to here, and then back to here. All right. Yay. All right, great, fantastic. Now, I understand there are probably several different variables here that I built into this, just quickly, not even really thinking hard about this, in order to sort of make this thing move and change, right? And therefore, to shade more or shade less, to be more spiky or less spiky, more expressive, less expressive, more dangerous, less dangerous. I don't know. However you want to sort of look at these things, but I can, of course, change the depth of the height right here, right? I can go into the grid shell rather than out of the grid shell, right? So I can change that, and I can also change where I'm getting these peaks to sort of close this up more or close it up less, right? Okay. Now, I'm like really freehanded there with those multi-sliders, right? So let's think about this again, right? Similar thing, but with a slightly different recipe. It gives us a little more control over this. You with me? Yeah, you ready? All right. Well, I can tell how excited you guys are. Instead of dull expressions, I see like a hint of a smile occasionally, and like somebody under their breath saying, "Gosh, let's do this finally." All right, so similar, right? What do we start with? The quad, right? Okay, yeah. I'm not going to beat that horse here. What am I doing then? I'm connecting alternating vertices, right? So I'm making an X, right? So I'm taking one corner, the alternating corner, connect them up the line. Same thing with the others, right? And I take one of those lines and I identify a point along it. T, then I subtract T from 1 and place sort of a how do you say that? Not congruent, symmetrical sort of point on the other side, right? So as this distance gets larger, this distance gets larger. Right? So they might move together and they're constrained along this axis. Now I just have one slider and it changes to open or closed, right? And then more open or all the way closed. All right. So we're doing it slightly different. Instead of sampling the surface for two UV coordinates with those points, we're drawing a line across and then we're constraining it just so that we're getting those peaks along that line, like a rail car. Okay? All right. So yeah, why not? Let's try that. Now, if this was you, I would say save this and then save as, and you can start to modify this. Instead, I'm just going to go and yep. Okay, back to this. All right. So I have my quad. I've blown it up and exploded it into its constituent pieces, including 1, 2, 3, 4 vertices. Right. The next step. Let's draw a line. Let's connect up those vertices. Let's make an X. Here we go. I'll connect this point with this point, right? The alternating vertices, and we get an X. I can do this with the other one as well if I want, the other set. In fact, if I do this across a whole grid of quads now, and I type those, I get a diagram, right? It's pretty cool. Anyway, so if you like diamonds and like into Norman Foster and John Nouvel, maybe, this is right up your alley. However, I really only need one of these. Yeah, so let's just take this line. All right, now, let's refresh our memories. It's been a little while, but you're here with trusses, right? We can divide the line, or we can just give one T address and find one point along that line, right? Let's do the T parameter, right? Go to the curves. There's that T parameter. Evaluate curve to T parameter. We'll plug this in. Similarly to the surface, right? We'll right-click on that input and say reparameterize it, right? What that does is this line might be like 0 to like, it might be like 29 units long, right? 29.6001. Right? So what we want to tell is that this is 0 and the end is 1, right? So as we parametrically start to work within that, we can snap to the midpoint with 0.5 or a quarter point with 0.25, or snap to one of those ends with a 0 or 1. We don't have to try to guess its length, which is really odd, right? Okay, and very situational. Okay, so we need to give it a T parameter. In this case, I'll just give it one number slider. Here we go, just the standard old college try here. There we are. And go to 0, 0.25, 0.5, blah, 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 blah. All right. So let's say we're going to put one somewhere over here, similar to our 0.75, 0.75, right? But in this case, it's never going to deviate from that line, right? That diagonal that we just drew. Yeah. All right. Now, if we want to have something from the other side, right? This is 0 and this is 1. What we can do, since we know that this is 1, we can do a little bit of basic arithmetic. You guys might have heard of this. It's called subtraction. Right? And so what I'm going to do is I'm going to say 1 minus whatever that T parameter is, right? So I'll plug in this as the input to subtract from A. And for A, I'll just right-click and say set the data item as 1. Okay, so 0.83. And this is set as 0.17, right? So 17% along the way from the start, we'll get a point. 17% away from the end will also get a point, right? 83% of the way from the front end. All right. Happy routing, I guess. All right, so here we go. Right, now we get this point as well as this point. And they both update like that. They even kiss in the middle. Look at that. All right, so. Right, what's next? It's mostly from here, just like the other recipe, right? We got to project up at start point, direction, length, find those peaks, and then start connecting the dots again, right? All right, let's do that really quickly. Right. So I'm doing this for this bird's mouth thing, and maybe some of you have something similar, and if so, man, you're really getting some ideas here. But you, over the weekend, are doing it for your component. If you need to start to make adjustments, that's fine. I wouldn't go too far off what you were trying to do. If you need to simplify or start to understand that maybe you didn't quite get the logic of the full triangulation, and now you need to start to triangulate some things, that's fine, right? Okay. I would argue that every step of the way, whether we're drawing it, modeling it, prototyping it out of paper, prototyping it digitally, every step of that way is part of the design process, right? So if you need to start to adjust things, do it. Go for it. Okay. So what do we need to do? Oh, yes, right. Up. There we go. All right. So let's see. What we're going to do for that. So I can project up a certain length from each of these points, but which way is up? In this case, it's Z, right? Because I just drew a generic planar surface on the XY plane. But if I suddenly change the orientation of this plane, right? I need to look at this surface and find some sort of normal condition for the surface to use as the direction, right? So then if I change the surface, its orientation, everything will change along with it, right? If I just use Z, and I rotate this 90 degrees, right? Then suddenly everything will be flattened out because everything's projected in Z. But the surface is also lying in the XZ plane, right? So that wouldn't be any good, right? We always want to be sort of perpendicular to the surface as we project out, right? In this case, it happens to be up, but it could be to the side, right? Particularly if this is let's say, a panel on an envelope to the side of the building, right? Suddenly you have to project out. Project perpendicular to that plane, right? Okay, so fortunately, we can do it similar to what we just did before, right? We can evaluate the surface at a UV parameter. Evaluate the surface. There we go. And plug in the surface. We'll reparameterize. And then we'll just give it this is already set to 0.5.5, right? It's going to give us that normal direction there at the midpoint, right? This is great since this is a plane. All we really need to do is sample one point on this and we understand where the normal is, right? Okay, great. So now we're ready to start to project upwards again. Start point, direction, and length. Here's start point. Here's our direction we just made. And a length. I guess I didn't have to blow away that old, well, okay. Let's see. -10, +10, I believe is what I used before for the minimum maximum. And we'll plug it in there, make a copy and paste, just replace this. There, yeah, not too bad. Right. And we need to find the endpoints then of those verticals that we just drew, right? Yes, same as before. Right, we want to find the points because we're connecting points up, right, with the triangles. To make these triangular surfaces, the ingredient are points, so. All right. And yeah, from there, let's see. Let's do this. I'll just quickly try to figure this out here. Move from here to here. Let's see, where's that? Where's that? So we have this to this, so this guy over here, let's see. So it'd be this one. Oh. There. All right, let's do this again. Yay, this never gets old. Actually, it does. All right, so we have that, and this, and this one. Yeah, there we are. All right. So there's one half of the bird's mouth. Do you ever like look at these and go, these really need to line up? You know, you can do that here, like, and then actually space them apart with these. Yeah, right? You'd think I would do that, like I'd be a real, but yeah, anyway. Sometimes it's helpful to sort of try to line these things up a bit, especially if you like come back to this a month later and you're like, what the hell is this? I don't even remember, right? Okay, so let's see. We can go from this point to this point. I believe it would be, let's see, that to that. Yeah, okay. So here to here to there. And last but not least, let's see, this one to this one, and also to this one. There we are. Yeah. Ta-da! All right, now what's nice about this is that we can constrain this, and then we just have like sort of open and close, right? So we can even have them go past each other, which I don't recommend trying to do that off chipboard. It doesn't really work so well. Jello maybe, but otherwise, you know, we could always constrain this from 0 to 0.5 actually, and then avoid that condition. Yeah, why don't we do that? Makes sense. Yeah. Now we can go slam, boom, open, closed, or a little between. There we are. All right. We can even animate this and make it look like it's talking to us, and like voice over something silly like architecture is great, right? So, I forgot I was recording this. I shouldn't say these things out loud. There's nothing stopping us from doing all kinds of interesting things, right? I mean, it's few parameters, right? So let's say, for instance, I kind of like the idea of instead of going up, going down, right? Or maybe one side goes up and the other side goes down. Oh, yeah. Oh, sometimes I impress even myself. All right, so here we go, right? Here's the parameters. Right now, 7.988 units high, right? Or up in one direction. Then we use that as a direction, we use it for, sorry, length here and length here, right? There's several different ways we can do this. We can multiply this by -1 before we plug it in here. Yeah, watch. Then we just go back to our math and do a little multiplication widget. We could say multiply this, whatever this is, it's a number slider, so it'll change that variable. Take whatever it is and multiply it by -1. So we plug in -1 for the bottom, and we plug that in down here, right? And now suddenly we get this. Hot damn, now we could go further than 0.5. In fact, that could actually be pretty interesting, right? Oh, this is like the mother load. Wow, this is crazy. Man, this is like shading component euphoria, nirvana here. All right, so, right, you can begin to play around with this stuff. Maybe play around and show me 3 different ways of how resilient this component is to respond to particular conditions. Right? So you can say, you can change the shape, it can open, it can close, it can go in between, or whatever, right? You know, it's kind of an interesting sort of multivalent way of thinking about these things. You can start to make them perform in a number of different ways with very small change in the numbers or the order or the rules, right? Just like any recipe. You swap out vanilla extract for peanut butter and you get a completely different type of cookie, don't you? Right? Same thing here. The small change in the recipe can lead to disproportionate change in the sort of output, the quality of it, or the shape of it, or the way it works in the world. Okay, so, which is great. I think systems like that are always pretty interesting. They're much more interesting than the boring ones that architects usually deal with, like this. Right? Restack them. Right. Okay, anyway. Does that make sense? Right? Do you guys feel okay about this? Remember, try your best. You try your best, I can always tell. Because you even when you're like, I've failed completely, and you come to me with questions, like on, you know, sometimes it's really poor timing, like Friday evening or something like that, and I go, well, okay, yeah, let's, you know, that's great, right? Fail really fail often. All right, so here we go. Should we make this even different? Yeah, we can always build off of this, right? We sure can. In fact, let's do that right now. All right, so I was actually thinking about this little guy right here. And so if we wanted to introduce an additional fold that goes from the peak down to, let's say, the midpoint, and then start to push things in. What we can do is we can actually draw a line from midpoint to midpoint to midpoint to midpoint across, and then again find points along that, and then we just start to make additional triangles, right? So instead of making one big triangle for each side, we make two smaller triangles that meet up in the middle, and that middle point is something that can inflect and move along that line, right? Hold that thought. Let's demonstrate that, right? Okay, so new. You're like, wait, what happened? Right? Okay, there we are. So let's bring this in again, parameter. Let's find surface. There it is. Right click, set one surface. Grasshopper disappears, allows us to pick the constituent piece of geometry and line that we want to reference back into Grasshopper so we can build off it parametrically. There we are. All right, so got $1 for every time I said that. I would be tired. Yes, so let's talk about what we're doing here. Right, we have this quad, we're going to explode it just like before. Yep. Sound effects are, of course, optional, but always appreciated, at least to me. All right, and then this time instead of vertices, we're going to play with the edges, right? So here's a list of 4 edges, right? I mean, it's not hard, right? This is a quad, it's a rectangle. Well, not even a rectangle, it's a quad, it's a 4-sided polygon, right? And actually it's going to have 4 sides or edges, right? That's what that means, edges. All right, so the sort of curves between the vertices. Let's see. Here we have the first one with an index of 0. Copy and paste, copy and paste, copy and paste. Just change these indices really quickly. Right click. Oh, come on. No. There we go. Set integer. Third one will have an index of 2. The fourth one will have an index of 3. And I'll try to type in 3 this time. All right. I'll even straighten these up. Look at that. All right, great. So, justify. Keep me space. All right, so what's next? Oh, right. We're going to take each of these edges. We're going to find the midpoints along them, right? All right, let's do that. These are curves or lines, right? Line-like curves, actually, it says. Look at that. Something satisfying about seeing that. I don't know why. All right, so let's see. We'll plug this in. We'll reparameterize it. And then we'll give it 0.5 as a t parameter in order to find the midpoint, right? 0.5, click, plug in, copy and paste, paste. Might as well line these up too. I mean, look really weird if they weren't now, right? Oh, yes, and then plug in each curve the way we need it. There we are. Yeah, look at that. Okay, so we have a point there at each of those midpoints. And if we wanted to, we could take alternating ones, right, and do the same thing. Yep, there we go. All right. You know what's interesting about this one? Maybe I'll change this up a little bit. You know, instead of making it just the open and close like this, what if I just build a peak for a pyramid there, and then the openings are just happening over the edges, right? So you can begin to sort of play around with this and redesign or sort of begin to modify and change things as you go, right? So if I wanted to find the intersection of those two lines, right, in space, I could do a line-line intersection, right, a curve-curve intersection. That works really well when we have a planar quad, right? Because then this always going to intersect with this. But if we have something that's actually kind of doubly curved, you might have lines that don't actually, they might look like from the top that they intersect, when we look at it from the side, they might not, right? So in this case, I'm just going to go ahead and find that midpoint along the surface, right? We can do that by evaluating the surface at a UV coordinate. UV would be 0.5, right? Halfway in both directions, right? Okay, so is this starting with a little bit of practice to start to make more sense? Practice is what helps. Even my awesome YouTube videos are of limited value. Awesome, whatever. If you don't practice, right? Don't become an expert by watching a YouTube video. It's by like hours and hours of applying stuff, right? There we go. And in fact, what that also does is that gives us the normal direction as well. All right, so start point, direction and length. Let's see, curve, here we go. Start point, direction, and length. Here's the start point, here's the direction. For the length, let's, man, I wish I could just set this as default for, well, I guess actually 0 to 1 is actually pretty handy. There we go. Just make a peak point there. All right, now back to these lines, because that's what we were here for. Yeah. So just like before, when we were constraining these things to 2 points on either side of the line and they just converge to the center, we did a similar thing with these new lines that we made, that we drew from midpoint to midpoint across the quad. Almost sounds like we're talking about a physical, like, geographical place, like we crossed the quad at the university. All right, so, right, so curve, we evaluated a t parameter, right? We gotta find some points along this curve. That's the tool to do it. We give it some sort of t parameter, t value, t address, and then it places a point at that address, right? So here's the curve, gotta reparameterize it. And there's a number slider. All right, there we are. And not only that, but I think before, what did we do? We also took this value and we subtracted it from 1, right? So that we'd have a sort of point on the other side, also the same distance away from the end point, right? As this first one was from the start point. All right, so subtract this from, and for A input, I'll say 1. That's never going to change. I'll plug that in for this t, right? Now we have these two. You can see them sort of moving together. All right. Love it when a plan comes together. Okay, let's see. Copy, paste. This time we'll use this line for these, right? Aha, success. Look at that. Can you guys see that? See the green points right here? This is like synchronized swimming. Dun, 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 dun. Right? Okay, so from here, it's a simple matter of finding that peak point, finding the points that line that we drew, and then starting to connect dots between the vertices, those lines, you can see the values, and then the point. Okay? Do I need to do that? It's kind of a pain. Might as well, we have time. All right. The more points you get, the harder it is to keep them straight, right? And so that's why I like to start to try to rearrange these so that geographically, like I start to make a quad with them, so I can start to like cognitively understand, well, which one's which, right? When I'm facing the model. Or if something's up high, something's down below, I start to place them in y-axis accordingly, or whatever. So let's see. There's the start point, direction, length. So there's the end point for that bad boy. And let's go to surface. Each of these are going to have that peak in. So I'll just go ahead and, before I copy and paste anymore, I'll plug that in. Now I'll make a copy of that. We're going to have 1, 2, 3, 4, 5, 6, 7, 8. Aha, 8. I have to do this 8 times? Oh, yeah. All right. The things I do for you guys. All right, 4. There we are. Great. And now you're starting to see that this precious screen real estate really matters now, because I'm trying to see what's going to happen in Rhino with my perspective view, at the same time trying to sort of isolate widgets in different places, right? So this is where I might actually start to rearrange things like this, so I understand which one is which, right? So this one is here, right? I'm sort of forming a similar polygon to the one that these 4 points are so just to keep them straight in that. Otherwise, it gives me a headache just thinking about this. What's this one? We still need to get the vertices out, don't we? Okay. Well, we can pull out 4 items, the first, second, third, fourth, with these. We'll just we'll make a copy of them and replace edges with vertices. There we go. Oh yeah, look at that. 1, 2, and we can arrange these as well. So there's that one, and then there's this one up here, and there's that one. They go around counterclockwise in this case, to my view. Interesting. All right. That's just super duper. All right, so, yep. Let's try it. I have this one down here. I have this one up here. Let's start here. I'll plug this in for B, and I'll plug this dude in for C. There we are. Oh, so far so good. All right, and then where I left off here, let's see. This one needs to plug in, but then also this one needs to plug in, right? Yep, there we go. Now let's test this. So far so good. We can make this thing look like it's sort of like inhaling, exhaling, right? Or letting more water in or less water in. They can start to sort of umbrella, telescope in and out in particular ways. And in fact, there are ways to actually make this into some sort of connected device. The key thing is that if you look at this as a triangle from the side, those sides are always changing their length, right? So if you don't constrain things to their length, is the hardest part with that, right? But you have to start doing a bunch of polar coordinates and things like that in order to do some vector mathematics. Again, I don't want to make my head hurt this time of the week. So I'll stop mentioning those terrible, terrible terms. All right, so let's see. There's that one, and I need this point right there. Oh yeah, look at that. And I need this point over here as well. And I need to plug it in with this one. Haha. Great. Yep, so you can see what I'm doing, right? I'm just sort of making my way around this dude, this thing. And, yep. So let's see, this point with this one, that would be this one here, yep. And this one with this guy right here. And I just keep going around. Let's see. So wait, this one here. This one's going to go for both of these. So I'll just plug them in for both B's. And then we have this one down here. And then we have this one up here. Oh yeah, look at that. Okay, so now I can begin to sort of make this thing open up or close, right? Great. Now if I'm going to combine this with bird's mouth, I can copy and paste all of this mess, spaghetti bowl of stuff, into the other one, and just start to make sure we connect up everything accordingly, right? It looks something like this. Bird's mouth 03. There we go. Yeah. So it's a little messier. Set one surface. Let's turn this on. Yeah, there we go. Let's turn this off. Let's turn this off. Yep, there we go. So now we have, oh, we can even, oh, look at that. I forgot about that. That's so good. All right, so we can open and close the periphery. We can also open and close the center, right? In fact, in this case, I'd probably constrain this to 0.5. Right. And then, of course, we could always add a little bit of a twist if we were really going at this. Wow. Incredible. All right, so you can begin to see that the sort of matrix, depending on how many variables you have, the sort of matrix of possibilities start to exponentially multiply. Right? Now what's interesting about this is, I mean, it's okay a component. Now imagine like somebody saying, "Where are these bad boys?" and start to change, right? You don't have to do this over the weekend. Am I clear about that? What I'm about to do next? Yeah, let's plug in a list of quads. Why not, right? I mean, what's the worst that could happen? He said right before his computer blew up and exploded. So anyway, let's see. Instead of a quad, let's do, oh, I know. Here, I already have a surface or two in mind. Space frame truss, grid shell example. Yeah, let's do grid shell example. Why not? Nope. There we are. Yeah. whatever. So let's bring this surface in over here out of the way for a moment, and let's start to do something to it. Right, so the next step that we'll do in this weird process why is there a red? Oh, I see. It's because, got it. Silly me. Okay, right. So here's a grid shell sort of, or shell sort of geometry, or whatever. Let's see. I want to divide it up, right? I want to divide it up into a set of quads. So again, you don't have to do this part over the weekend at all, right? But I'm just sort of showing you where this is going. Trim this out, the two-dimensional domain. What kind of two-dimensional domain? Let's determine that. Divided two-dimensional domain. Here's the U and here's the V. 10 and 10. It's already set to 10 and 10. That works. Base domain. So let's make a two-dimensional domain. Construct a two-dimensional domain from 4 numbers. 0 to 1, 0 to 1. That'll work. Plug that in. Actually, here, let's plug that in. There we are. Oh yeah, look at that. So now we have 10 divisions in either direction. We have 100, checkerboard of 100 quads. All right, now, let's see what happens. And it might blow up, right? So the thing is, right, here I have one surface, right? And so it's easy to get 4 things, right, because it's a simple list. As soon as I plug in more than one surface, I'm going to get a list of lists, right? So I have 100 quads, and each of those have 4 vertices each. So I'm going to have 400 things. I'm going to basically have a list of 100 4-point lists, right? Kind of weird, huh? So we're going to have a data tree, and let's just see what happens. I've seen worse things happen. Okay, so far so good. Now, here we have an issue, and that is each of these faces. There we go. Oh, I'm so smart. And modest. Oh boy, okay, so let's see. Let's turn the preview off here, let's turn the preview off here, and let's see what we have. Oh yeah, look at that. So now, as a group, we could begin to open these things up or close them down, right? Or twist them, or turn them, or open them up or close them down, right? And the other thing that's interesting is right now we're doing that globally, so we have one value for this or that or the other, right? But if we said, well, this is facing southwest and that one's facing northeast, and we actually get the solar values for how much solar data is hitting this, and we say that one's extreme, needs to close up, we can begin to give individual values for these and start to create gradients, where some close up and they gradually open up, close down and they gradually open up, right? Depending on where those red and blue areas are in that false color map, where the sun solar radiation average over here is, or whatever it is that we're measuring. I'll actually give you, for our exercise on this, several lightweight directions that you can begin to optimize for when it comes to this, right? So we actually close that feedback loop. Instead of saying, well, does this shade? Now let's adjust and then let's remake it and take it outside the sun and see if it shades better, right? We can actually take the solar values, the solar radiation values, plug them in as part of the recipe for the design, right? Baked into the logic of the component system, and optimize digitally so that we actually know what we're doing ahead of time. So we don't have to sort of simulate things in order to test. We simulate things in order to sort of plug in that data to avoid having to test it. All right, so that's the deal. Pretty cool, huh? Yeah, I mean, I wasn't so fond of this until I saw like 100 times. 10 by 10 looks pretty smart. You know. Let's see, -10, 10. And again, everything flows from left to right still, so I can make this deeper or shallower or whatever. Right? Spiky, less spiky, more spiky. Make it look like it's growing hair. Armadillo. You know, that looks like something in the Mojave Desert, right? I mean, look at plants in the Mojave Desert, they're mean. You know what I mean? Like, you have to survive out there, right? I mean, it's one thing to sort of gather up a little bit of resources in the soil, but then to sort of also try to prevent you from getting eaten by a bird. You know, say, if you're going to take me, bird, you're going to lose an eye or something. So, all right, so, an eye for an eye.